So, hello everybody. Sorry about the messing about. It's not working at my end quite the way that I'd expect it to. Oh yeah, I can see it now. It seems a bit weird to start at the end of the first week of teaching to say welcome to the course, but you know, this is where we start. So what I'm going to do is I'm going to take you through the course and I'll let you see how we plan to do this. Just so you know, this is being recorded and I will post these on a site called My Baseline. I'll give you details on that in a minute. So let me share the screen. That's the place to start. So if I click on that and say share this screen, share it, and with a bit of luck, yeah, there we go. So F11, so we've got full screen. F11, so we've got full screen. Right, so we're doing Maths 1, okay? Right, yes, we're doing Maths 1, and we've obviously got two courses. There's Maths 1 this semester and Maths 2 next semester. And what I want you to get from the beginning is that this is more about understanding maths than it is about understanding algorithms. What do I mean by that? Well, let me tell you. Let me have a whiteboard. Let me pull a whiteboard on. You can see what I was doing recently. So let's delete all of that. Delete, get rid of all of that. Right, imagine you have an algorithm called FOIL, which a lot of you probably know. And if we've got A plus B times C plus D, right, how FOIL works is that you multiply the first terms together, which are those two, so you get A times C. Then you multiply the inner terms together, which is the B and the C, so you get plus B times C. Then you multiply the outer terms together, which is that the A and the D, so you get A times D. And then finally you do the last terms, which are the B and the D, so we get plus BD. Okay, so that is an algorithm, and the person who's done it, me in this case, has followed this algorithm which says you multiply the first terms, the outer terms, the inner terms, and then the last terms, and that's your answer. Okay, it's correct and that's fine, so it's worked fine. But what happens if you get A plus B brackets, oops, let's just rub that out because that's not what I wanted, and go back to the pen. A plus B, C plus D plus E. Right, if you get that, you're dead, because FOIL only solves this sort of problem. It doesn't solve this sort of problem, okay? And what I'm interested in is that you learn what is going on rather than just quick algorithms like this, because that doesn't really help you. It doesn't get you to where you need to be as, you know, future engineers. As future engineers, you need to have a robust toolkit that allows you to answer questions that you've never met before. Okay, so the course is about understanding rather than about using an algorithm. Okay, I want you to get a handle on what the question is. Right, so you are allowed to get the answer wrong. In fact, I'd go further than that. I would say you should assume your answer is wrong until you've proved that it's right. So if I give you a calculation and you bash it out with a spreadsheet or a calculator, what you get must be assumed to be wrong, and therefore you've got to then take some effort to show that it is actually right. And that's why I talk about a sanity check at the bottom of the page there. I'll go into more detail on that later, but this is just what the course is about. Okay, now click on here and then go on to the next page. Right, we're going to use something called Agile Maths, which is something we developed here at Aston. And let me just tell you, Agile is a project management methodology, and I suspect many of you, if not most of you, will probably use Agile for project management when you're in industry. Okay, so the reason I'm using it here is just to get you used to the vocabulary. So Agile has sprints and scrums, which is what we're saying here. A sprint starts with a lecture today. So this is the beginning of a sprint that we're in now, and this sprint will last until midday next Wednesday. And in that time we're going to deal with numbers, which is on the syllabus for our first week. Okay, and then we have scrums. Now, if you were in industry, a scrum would be a session that you would join with other people in your team, which is 8 plus or minus 1. You wouldn't even sit down, you'd stand up and you'd have a short meeting about how the project is progressing, and then you'd all decide what you're going to do, and then you get on and do it. What we'll use the scrums for is to go over the material that has been delivered in the lecture. So today's lecture will be on numbers, and the scrums next week will be on parts of that. Now let's just talk about that to see how that works. The groups in the scrums are going to be 8 people. So 4 of you I will invite, I will require you to do a presentation next week on something to do with numbers. Now imagine 4 people all did the same presentation. That will be interesting, wouldn't it? Not in the slightest. So what we need to do is whoever's giving the presentations in your groups needs to discuss with the other ones in the groups who's doing what and how can we put this together in such a way that it's interesting for all the other people. Okay, so if you do a presentation next week, the other 4 will do a presentation the following week. Then it's back to the first team and then the second team and so on. So over the course of the next 8 weeks, you'll do 4 presentations, and the other people will do 4 presentations on the, if you're doing the odd weeks, they'll do the even weeks. That's how it's going to work. Okay, if you do a presentation, you get a mark for that, and that goes into your coursework mark. If you fail to do a presentation, you don't get a mark for it, and obviously that doesn't go into your coursework mark. Okay, I'll give you more detail on that in a minute, and I'm sure there'll be some questions that will come up as well. Okay, so scrums, yes, I've just said all this, haven't I? So a scrum is a group of 8 students plus a scrum master. And the scrum masters are the people who are here in the session at the moment. So 4 people present an element from today's lecture, and then the following week it'll be 4 people presenting from that. The role of the scrum is to make sure that everybody understands what's going on. There are actually 2 things going on here. The way to learn something is to teach it. That's how you learn something. So you doing a scrum, doing a presentation, actually it cements it in your head. So the person that learns most from the scrum is the one who's doing the presentation, and as it says there, you get marks for the scrum. Okay, and then we have online tutorials. So each week there is an online tutorial. It starts today on Thursday and it closes at midday next Wednesday. Okay, let's go and have a look at the online tutorials. Okay, I click on my baseline and I'm now at, let's just make that a bit smaller so you can see the address here, https://www.mybaseline.org, and that should be Maths 1, not Maths 2. Okay, so Maths 1. So that is baseline. And let me just walk along here. We've got the textbook, which covers the topics that we're going to do in Maths 1. So we've got numbers, algebra, equations, and so on. Then we've got resources here, which is something that grows as the course develops. Okay, so we've got past papers, we've got videos on particular subjects, we've got all the revision topics, and we've got frequently asked questions, which at the moment don't have any questions in it because nobody's asked me anything yet. But as the course goes on, that frequently asked questions will get more and more content in it. The other thing that will happen is I'll add to this drop-down list here the lectures. This lecture, the video of this lecture will be added in there. Okay, and that will be in 2 parts because we'll have a breakout part way through. So there'll be a video on this first part, then there's a breakout, and then there's a video on the second part. I'll give them some kind of name or something. Okay, so if we go into textbook, we've got numbers, and that's what we're going to be doing today. And if I go to the bottom of numbers, you can see that there's some examples down here. And these are the sorts of questions that I would expect you to understand by the end of the session. Now, you can put your answers in here. So 236 in binary, if I say that's 1, it'll say no, you've got that wrong. And if I were to put the right number in, it would tell me, it would give me a tick, obviously. 21 hex in decimal is 33, so if I put a 33 in there, then it says I'm right, and if I put a 32 in there, it says I'm wrong. You can enter your answers into this, and there's no cost, there's no it's not being recorded, there's no black marks against your name. You can just do this until you get it, until you understand the difference, in this case, between binary, hex and decimal. Again, with the powers here, this question, you've got to do some analysis to work it out. But look at this. If you want a squared, you write it as a, and that thing there is called a caret, which is the shift and 6 key, and 2, so that will be ax squared. If you've got more than one character, like the B12 here, then you've got to put it in brackets, or -2, you've got to put that in brackets. Okay, there is here, under the question mark, something that tells you how to do it. So if you want x squared, for instance, let's stick that in there. If we say x squared and click the test button, it says that's what it actually means. So down this side is what you type, and then down this side is what you'll get. But it does do the analysis for you, and it breaks, so you can check out your arithmetic before you put it in. Again, I'll do that in more detail later on. And then the other thing I want to show you is the login. So if I log in as Tom, you would put your student number there, and then in the password you'd use your university, just your ordinary credentials. So if I put mine in, see, tutorials has popped up now, and we get a string of tutorials. At the top we've got my progress, which at the moment won't have any progress because I've not made any. If I go to algebra, which is next week's topic, it says this isn't available yet. And if I go to numbers, it shows me my effort at this week's tutorial, which, as you can see, is probably not right. But if I want to change this, if I want to put 10 in there, I can put 10, and if you watch the top of the screen, it says my answer has been updated. So it knew I already had an answer, and it's updated it. So what was 1 is now 10. Neither of them are right, just for the record, but it records it. So you can do this as many times as you like. You can just carry on 100 times, 1,000 times if you want to, up to midday next Wednesday, at which point it closes. And once it's closed, that's it. You don't get another chance at it. It then gets marked, and you'll get the marks sent back to you in the My Progress, which is here. Okay, I'll go over that again for anybody who wants me to, but for now I'm going to log out of that. Let's go back to why is it not doing it? Is it there? No. So let's do, there we go. So we've done that, Maths 1, Agile Maths, Scrums, online tutorials, and you get marks for tutorials. Okay, so now we're talking about marks. Let's just look at the marks. You'll have an exam at the end of January, or more likely the beginning of February 2022. The date isn't set yet, because if it was I'd tell it to you, but it will get set around November time, and as soon as we've got it I'll share it with you. Chances are you'll get it before me, is the truth of it. 70% for the exam. The tutorials you get 20%, and for the Scrums, so the tutorials are the online tutorials, so the questions that you'll get on a weekly basis, there are 10 of them, so each one is worth 2 marks. And then the Scrums, you get 1 mark for attending and 1 mark for doing a presentation, which, if you think about it, is going to give you 12 marks, so that gets factored down to give you a total of 10%. Okay, 70 plus 20 plus 10 equals 100, and that's where the marks for the module come from. Okay, right, books. So Baseline has a textbook built in, we saw that. I was looking at the different topics that are there. But if you are the sort of person who likes to have paper books, the Bird's Engineering Maths is the one that we recommend as the course book. Stroud's Foundation Mathematics is a good book, particularly for people who like a lot of detail. There's an awful lot of detail in Stroud. And then Statistics Without Tears, Derek Roundtree's book, that is more for section B on the exam paper, and I'll talk more of that a bit later. Okay, and then the PALS. Now, I understand most of you turned up to the PALS session yesterday. PALS stands for Peer Assisted Learning, and as those of you who turned up yesterday saw, they are ex-foundation year students who have agreed to help you, the current foundation year. So that is 1:30 on Wednesdays in MB 706, and it's there if you want it. It's not mandatory. It's there if it helps you. Okay, the PALs are students who've done well on the foundation year and they understand what they're doing, and they are given the content on a week by week basis. So for instance, if you go and see them next Wednesday, they will know all about the stuff we're doing today, about numbers and binary and all that sort of stuff. So that's the PALs. And so if you turned up yesterday because it said it on your timetable, that was a bit of a mistake. It should have said optional on it, but now you know it's an optional process. Okay, oops, wrong way. And then I think finally, the Learning Development Centre. Yeah, the Learning Development Centre is based in the library, and they have drop-ins at different times of the day. You can check with them what times they are because they do change. And you can go along to them with any, and I do mean any, mathematical problem. So you can go along with problems that you might experience with Maths 1, but you can also go along with problems, if you're doing some design work in mechanical or electronic engineering and you don't know how to do something, you can take that along to the LDC, and the people there will be able to help you, or if they can't, they'll know somebody who can. Okay, so that's in the library. And then emails. If you need support from anybody on the course team, you can email them, but we do need you to email properly. So you need to use your Aston email address, because emails from other places like Hotmail and things like that often get blocked by the security in Aston's email server, I should say. So don't use Gmail accounts or anything like that. Use your Aston account. Okay, always include the module code in the subject. There are many of us teach on more than one course, so if you just send an email, we've no idea what course you're talking about. So make sure you put the module code in, and for Maths 1 it's SE0MA1. Okay, SE0MA1 for Maths 1. And you should always have a meaningful subject. So just saying urgent isn't really very helpful. Give us a clue as to what it's about. And then finally, always sign your email. So I say regards Tom, which means that I'm telling you that that's what I'm expecting you to call me. So if my name was down as Fred or something, but I signed it as Tom, then I know that what I want to be known as and what is listed are not quite the same. So if you happen to be called Duncan and you really prefer to be called George, then just sign it as George, so then we know what you want to call yourself. Okay, so that's emails. And then any questions? I'm going to open that up and I'm going to pause here for a second just to see if there's any questions.
Yeah, Tom, I've got one. Would you mind going over what the calculators, basically, what calculators can be used in PALS?
Right. Yeah, okay. Sarah, can I come back to that? Because I don't have the current list of calculators. Yeah, I'll sort that out whilst we're in the Scrum sessions, and then I'll have the list, because I know there's a website with it. Yeah, so He writes a note to himself, calculators. But you know, if I had my way, there'd be no calculators. Calculators rot your brains. Okay, are there any other questions coming in?
Yes, let's have a look. We've got, what should we do if it is not letting us log in?
Email me is the best thing. If it's not letting you log in, email me.
Okay.
And
you.
don't forget the email protocol, so I know what I'm looking at.
It's just pinged on through, yeah. Okay, there was one. Can you talk in more detail about the groups, please?
Yeah, can I ask a question? Have you got the sessions for next Tuesday and Wednesday, the maths, they call them tutorials. Have you got the tutorial sessions in your timetable for next week? Okay, so some have and some haven't. Yeah, not the pals.
No.
It's Tuesday and Wednesday, and they start at 0:00.
Yeah. Last time I looked, Tom, the group 1 was sorted. I think we're waiting for the others to appear.
Okay. So what will happen? Basically, they've not been set up yet, so we're just going to show up in a room, and then we'll sort the groups out. Then that's what it's going to have to be. Okay.
Yeah. Can you show the slide for the books again, please, Tom?
Of course I can, and this will be recorded. This will be available. So let's go to the books, which is there. Okay. But as I say, this is recorded, so you'll be able to look at the video and see them.
Lovely. Thanks, Tom. And another question that's just come up. What do you need to get to pass this module?
You need 40% on all modules. So not just maths, all modules, you need 40% as a minimum. But I hope you get something more like 60%, because that's better than modules. Okay.
Thank you. And can you go over what a sprint is again, please?
Yeah, I just saw that. Yes. Yeah. Okay. So let me find the right. Scrums, no, sprints. Okay, we're using something called Agile. It's a management methodology, and the reason I'm using it is because it's very similar to what we're doing. A sprint, if you were in industry, a sprint is a block of work. So if you're developing a new aircraft and your job is to do the oleo legs, let's say, or the flaps or the engine or something, you would have a sprint on parts of that. So that's how it works as a project management tool. For us, a sprint goes from Thursday morning, which is obviously today, to midday next Wednesday, and it's a block of work which is whatever is on the syllabus for that week. So if I go into baseline, come on mouse, where are you hiding? There we go. If I go into baseline, let's have maths 1, not maths 2. Maths 1, because we don't want to frighten anybody quite yet. So today is numbers, so this week's sprint is numbers. So from now until midday next Wednesday, we're talking about numbers, and then the following week we'll get onto algebra and then equations, and so it carries on. Okay, does that answer your question on sprints? If you don't get the vocabulary, don't worry too much. I'm just trying to lay it in front of you, so when you get into industry you'll think, ha, I know all about this stuff, I've done it before. That's really what's going on there. Okay, right, now let me try something else, which is my baseline.org/poll. No, that's not quite right, so just give me a second, everybody, would you? I need to go. No, that's the one I've got open. So right, Right. So list accounts and go to my baseline and go to PHP my admin. Right, so one of the things I would like to know is how people feel about tutorials. So if I go to there and change that. Right, so if you navigate now to https://mybaseline.org/poll, let me write that for you. So whiteboard is there. Let's drag that in there and clear that page. Clear canvas. Come on, clear. So if you go to let's have a pen. https://mybaseline.org/poll. If you go there, you should see this screen here if I refresh it. Okay, so I'd like to know, do you prefer tutorials in person or online? You've got to give your student number and you've got to click online or in person and then submit it. Could you just go to that address and enter your view on that? Okay, so some people are doing it. That's excellent. Just keep them coming in. Okay, that's about 75 done. I'll just give it a bit longer.
I think we're getting a couple of both answers as well in the chat by the look of it. Yeah, thanks for that, Mohammed. Don't mind either.
Okay,
well, so.
Yeah, I should have added that. So thanks for that, Mohammed. Yeah, I should have added don't mind. Oh well, you learn, don't you? Where do you answer? Okay, Abdirahman, have you gone to that web address? Just go to mybaseline.org/poll.
We'll just put it back in the chat again for you.
Yeah, I'll stick the whiteboard up. So there it is. Okay. Right, I think we'll call it a day at that. Next time I'll have some graphs, but I didn't have any data to draw some graphs, so next time I'll have some graphs so you can see them. Right. Yeah. Have we got a record of those, Sarah? The answers in the chat?
Yeah, I've got a tally going.
Okay. I'll add those into the database so we can see what people think. Okay. Well, if there are no more questions, I think it's time to get started on the content today. So let's do that. So if you, let's just clear my board because I'm going to be writing this out as we go, and I could do with a thing to remind me. There we go, so textbook. Okay, let's just talk about numbers briefly. The thing is about numbers is that you probably know more than you realise about numbers. So the first 10 numbers are obviously 0, oops, a pen, 0 to 9. Okay, so that's the first 10 numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you wanted to add one to 9, so I want to add one there, you've got a bit of a problem because you've only got 10 characters, and I now need to do something else. Now, you know exactly what I'm going to do. What I'm going to do is I'm going to set this 9 to be a 0, and I'm going to put a 1 in the next column. Is my screen frozen, or is it... Are we okay?
You're fine for me.
Yeah, okay. Right, so just think about what's happened there. We've got 9, I've added 1 to it, and so I've put the 9 to a 0, and I've added 1 into the next column. Now, you take that for granted. You probably learnt it when you were about, I don't know, 14 months old or 15 months old, something like that. But that is so magnificent. I mean, think if you were Roman. Can you imagine what this year is in Roman, 2021, in Roman numerals? Does anybody know what it is in 2021 in Roman numerals? I'll tell you that M is 1,000, and X is 10, and I is 1. Okay, very good, Syed. He's absolutely right. So it's going to be MM. Yeah, no, absolutely brilliant. Well done, everybody. MM means 2000, XX means 20, and then a 1 means 21. What about 1999? Let's go for a tricky one. Anybody have a crack at 1999? MCM XC. Yeah, okay, I'm amazed at this. I'm not sure I could have done it without a bit of prep. So MCM, that means 2000 minus 100, so that's 1900. And then we've got 90, which is 100 minus 1, so 100 is C minus 10, so that's the XC. And then we've got 9, which is a 10 minus 1. Okay, so that is 1000, 2000 minus 100, so that's 1900. Then we've got 100 minus 10, which is 90, which is there. And then we've got 10 minus 1, which is the 9 that's there. Okay, they didn't have this system for meaning that the position of a number is important just as the actual number itself. So just to review then, we've said to add 1 to 9 in base 10, you set the 9 to 0 and you go into the next column and you put a 1 in there. So now let's just think a bit about binary. Binary's only got 2 digits, 1 and 0. Okay, so if I start with 0 and then I add 1 to it, I get 1. And then when I add a 1 to that, I've got a problem because, again, I've reached the top of my available numbers as I did with the 9. So I do exactly the same. I set that to 0 and I move into the next column. Okay, so in decimal, so this is binary and this is decimal. So that's 1, oh, it isn't. That's 0, 1 and 2. And to add 1 to that, I just type 1 and that gives me a 3. And if I add 1 to that, that goes to 0 and we carry 1. That goes to 0 and we carry 1. So that's what 4 looks like in binary. And the system carries on. So it looks like 100. But in binary, that's the same as 4. Okay, you've probably already done that, so that probably doesn't come as much of a surprise. So let me take that away. Yeah, delete that. Because now what I want to do is to look at something called hexadecimal. Oops, let's have a pen. So hexadecimal. Okay, hexadecimal. Hex means 6, so a hexagon is a 6-sided figure. Decimal means 10, so hexadecimal is base 16, which is what computers use. So what you have there is you have 0 to 9, which is your first 10 digits, and then you have A, B, C, D, E, and F. So that's 1, 2, 3, 4, 5, 6. So those numbers go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, not 10. So after 9 we have A, B, C, D, E, and then finally we've got an F. So an F is the equivalent of 15. So let's just think about that. F in hex, and I'll put a little h there to say that's in hex, is the same as 15 in decimal, because it's gone 9, 10, 11, 12, 13, 14, 15, and that's the same. Let's just think about this in binary. So in binary we've got just look at the columns. You know hundreds, tens and units. So in the first column in binary it's 0, in the second column it's 1, the next column, start again. So the first column is 0, 1, 2, 4. So I've got for 15 and then we've got an 8, so it counts up like that. So to count in this in binary, I've got, let's take that away because I don't want that there. That's what I want to do. So my first, to make 15, I need an 8. That means I still need 7, so I need a 1 and a 4 and a 1. So in binary, that's going to be 1, 1, 1, 1 in binary. So F in hex is equal to 15 in decimal is equal to 1, 1, 1, 1 in binary. Okay, so I'm putting subscripts here. And what about this one? Can I give you a couple of seconds to work out A in hex? And this time I'm going to write 16. What's that in binary? Sorry, what's that in decimal and what's that in binary? Two and 10. Okay, so we're going to get 10 in decimal and we're going to get in binary, we're going to get an 8, we don't need a 4, we do need a 2 and we don't need a 1, and that's going to be in binary. And I put a decimal there, I want to delete that. Delete that, because really what I wanted to write is a 10 there and a 2 there. Okay, so if there's any ambiguity, you need to put a subscript. So H is one subscript for hexadecimal, also 16 is a subscript for hexadecimal. If it's decimal, you can either put a D or a 10 or nothing if it's obvious, and in binary you can put a B or a 2, or again nothing if it's obvious that you're working in binary. Okay, so that's how we can work on numbers with different bases. And if we go to, let me drag this, oh no, I've got it here, haven't I? So if I go to my baseline, this one, numbers, down at the bottom, we've got, down at the bottom, here we go. So we're going to be converting numbers between different bases. Okay. Right, 2, 3, 6. Let's take 2, 3, 6 as an example. So what we're going to do is we're going to take, let's clear this screen. Right, so we've got 236. If we have a pen, 236. So what I'm going to suggest we do is we divide this by 16. Okay, why am I going to do that? Because I get the two separate hexadecimal digits, and I'm going to suggest you divide by 16 whatever the system that you're using. So to divide by 16, all you have to do is to divide by 2 4 times. Okay, so 236 divided by 2 is going to be 118. Okay, 118 divided by 2 is going to be 559. 59 divided by 2 is going to be 9, and we're going to have a remainder of 1. And then 29 divided by 2 is going to be 14, and there's going to be a remainder there. Okay, so that means that, let's just think about that. We've got 14, have I divided by, yeah. So if you do 14 times 16, that will give you 140. 6 4 is 24, down 2 to carry, 6 and 2 is 8. So that's going to be 4, 2, 2, 2, 2, 4. And we've got 236, so the difference is 12, isn't it? So this is going to be the remainder that we've got here. So we've got hexadecimal, how to write this down the best way. So 236 in decimal is equal to 14 with the remainder of 12, is it? Right, now 14, can somebody tell me what 14 is in binary. Okay, so right, so we've got 14 has got an 8 in it and a 1 in it. That gives me 10. It's also got a 4 in it. So 14 in binary is 1, 1, 1, 0. And now what's 12 in binary? Yep, okay. So I'm going to leave a space there, and then 12 in binary is the 8 and the 1, and then a couple of zeros. So we've taken 236 in decimal and converted it into 1110, 1100 in binary. But whilst we're there, let's think about what 14 is in hex. So anybody tell me what 14 is in hex? Yep, okay, it's E, just so everybody gets it. So let's just think about that. We've got, this is binary, no, this is decimal, sorry, decimal, and this is hex. So 10, 11, 12, 13, 14, and 15 goes A, B, C, D, E, and F. Okay, so we said 14 there, so that's E. And we've got 12, which is there, which is C. Okay, so 236 is this in binary and this in hex. So if I go back to here, 236 in binary was 1110 followed by 1100. Okay, am I right? Yes, I am. So I put a space in there just for my own convenience. If you don't have a space in there, it's still right. Okay, it won't give you a problem. It's just, I find that easier to understand because you can see the blocks of 4. And if you remember, we converted it into hexadecimal, which was EC. I'll put that in lowercase, or I can put that in uppercase. Again, it doesn't matter. But if I put ED, say, then it'll tell me I'm wrong. So that's EC. So you can use this as a way of making sure that you understand how the numbers work. Is that okay? Because I'm going to keep moving. So that's numbers and bases we've dealt with there. And just so you know, let's go to the top of this. We've got numbers and bases, and there's a table of how the different values work and how you can convert things between the different values. Okay, right. Now exponents, I'm going to go through this quickly because you've probably already done this, but 2 times 2 is the same as 2 squared, 3 times 3 is the same as 3 squared. So if you take numbers, 8 is 2 times 2 times 2, 4 is 2 times 2, and so on. And an exponent is just a quick way of doing it. Anything raised to the power of 0 is 1. Look what happens. We've got 8, 4, 2, 1. So 8 is 2 times 2 times 2. Divide that by 2, we get 2 times 2, which is 4. So we've just reduced the power from 3 to 2. Divide that by 2, we reduce the power to 1. And just carry on the same sequence. We've gone from 3 to 2 to 1. So if I divide by that, we reduce the 1, so we get 2 to the 0. And it continues. So if I divide 1 by 2, I'll get 2 to the minus 1, okay, which is a half, or 2 to the minus 2, which is a quarter, 2 to the minus 3, and so on. So it just carries on in exactly the same way. 0 to the power of 0 is undefined. It doesn't mean anything. So don't ever bother saying 0 to the power of 0 is 1. It isn't. Nothing to the power of 0 is 1. Okay, so knowing that, we now can see that if you multiply x to the a times x to the b, you're going to get x to the a plus b. And that's how logarithms and slide rules work. I don't know if anybody ever saw the film Apollo 13. Houston, we have a problem, if that rings any bells with anybody. But what was interesting about that film is they had an oxygen tank blow up on Apollo 13. So it's part way to the moon, there's a big bang, and they're suddenly losing oxygen, which is having two effects, neither of which are good. One is you're losing the oxygen you need to breathe, and secondly, it's acting like a little rocket that's pushing you in the wrong direction, which again is not a good idea. So they say, Houston, we have a problem. So Houston has a look to see what problem they've got. And immediately a bunch of people get out slide rules and they start doing calculations. When the Apollo were going up 50 years ago, they didn't have calculators. They had slide rules. Okay, so dividing exponential numbers, which is what I'm getting onto now. 243 is 3 to the power of 5. 9 is 3 to the power of 2. So if you want to divide that by that, basically just subtract the exponents. So 3 to the power of 5 divided by 3 to the power of 2 gives you 3 to the power of 3, or 27 if you'd rather. Okay, and then if you multiply exponents, as in this case, so this is x to the power of a raised to the power of b, so that means you've got b lots of a to the power of a, which means that you're going to do it b times. So this then becomes a times b. This is a plus b here. Notice the difference. Okay, and fractional exponents. I'm sure you can see how that works, and you've done that before. Right, is that okay with exponents and so on? It's sort of a revision, so I'm assuming everybody's sort of already done it. Yeah, okay, so I'll keep going. Logarithms. We've got 10 to the power of 0, which we know is 1, 10 to the power of 1 is 1, and so on. Now, the log of 1, if you've got a calculator, and I will come back to calculators, log of 1 is 0, log of 10 is 1, log of 100 is 2. And you think, oh, okay, I get it. So the log is actually just the exponent there, isn't it? That's what logs are. So log of 1,000 is the same as log of 10 to the 3, and that's equal to 3. So the log is the power that you have to raise 10 to get that number. So when you take a log of something and it's a fractional number, all that means is that you're taking 10 to the power of that fractional number, and that will give you the number that you started with. Okay, so all these logs are base 10. The only two logs I'm interested in, and I'm not going to bother you with changing bases and all that sort of stuff, are base 10, which is what we've got here, and base to the log e. And the reason for base to the log e is many equations depend on log to the base e, where e is Euler's number, a natural number. Okay, so those are the only ones that I'm going to be interested in. Log to the base 10 on your calculator will have a button called log. Log to the base e on your calculator will have the letters ln. It just says ln, which is natural log, but they put the L first. So it's log natural, if you see what I mean. Okay, so that's what logs are. And then we get something like this. 3 log to the 2x minus 2 log to the 3x. So let me do that so you can see how these work out. If I can find my mouse, where you've gone to, mouse. So clear that. Clear the canvas. So what did we say? 3 log 2x minus 2 log 3x. Okay. So we had 3 log, was it log or log? Doesn't really matter, but I'll keep it the same. It was log. So 3 log 2x, 3 log 2x minus 2 log 3x. Right, now if you get a number like this at the beginning, you can expand that by writing that as log 2x cubed. Okay, so you know what I'm going to write here. So that's going to be log 3x squared. Okay, so 2 cubed, that's going to be log bracket 2 cubed, so that's going to be 2 times 2 times 2, which is 8x cubed, and that's going to be minus log, this is going to be 3x squared, which is going to be 9x squared. So 3x all squared is what I mean. Okay, so we've now got 2 logs here, and they're being subtracted, so that is the same as log of 8x cubed over 9x squared. Okay, Remember, division is the same as subtraction when you're dealing with logs. And so now we can simplify that. X squared, let's just use a pen here, x squared takes that out, so that is equal to log 8x over 9. Okay, so that's now simplified the expression, which is what we've done here, and we get to the answer of log 8x over 9. Okay, so some of the questions you'll have to deal with simplifying logarithms like that. Okay, scientific and engineering notation. We'd better have a look at that. Avogadro's number, as you can see, is a very large number, and it will be a real pain to write that down. Planck's constant, by comparison, is a very, very small number, and it will be a pain to write that down. So then we have scientific notation, which is, in this case it will be 6.022 times 10 to the however many characters are there. 34, as it turns out. Is it 34? Yes, 10 to the minus 34. Just forgot them for a second. And Planck's constant is 6.6 times 10 to the minus 34. Yeah, Avogadro is 10 to the 23 and Planck is minus 34. That's what it is. Okay, so that is standard notation. So let me go back to my board here and clear that. Clear canvas. So scientific notation is a number let's have a pen. A dot B C D times 10 to the power of E. Okay, that's the general form. So you have a digit, then a decimal point, and however many digits of precision you've got, times 10 to a power, whatever the power may be. Obviously, if it's 10 to the power of 0, you don't need to write it. If it's 10 to the power of 1, you just write 10. And if it's 10 to any other value, you would write the value in there. So now let me ask you, what is 400,000 bytes in scientific notation? So 400,000 bytes in scientific notation. Okay, excellent. Everybody's coming up with that. So that's going to be 4 times 10 to the 5 bytes. Now, if you had a file that was 4 times 10 to the 5 bytes long, and I said, how big's your file? What would you tell me? Would you say it's 400,000 bytes long? Good try, Mohammed. You wouldn't say it's 400,000 bytes long. You would say it's something different, like, well, let's just count those zeros. So we could go 1, 2, 3. So we could say that it's 400 kilobytes. That would be one way of doing it. Another way of doing it would be saying 1, 2, 3, 4, 5, 6. So we could say it's 0.4 megabytes. That is correct, and that is correct. Both of those are how we would describe a number like that. Sorry, that was meant to be pointing at the 400,000. So this is standard notation or scientific notation. These ones are engineering notation or preferred standard notation. So this is working in kilos and megas, and they could work, you know, if it was quantities, it could be millis, micros, nanos, and so on. So scientific notation is always a number followed by 10 to the something, whereas engineering notation or preferred standard notation, you use the closest kilo, mega, milli, whatever. Okay, so which one of these is right? The answer is both are right. So when you're giving an answer, you can either give 400 kilobytes or 0.4 megabytes, whatever is appropriate to what you're doing. Okay, so that is standard notation and preferred standard notation, or standard notation is the same as scientific notation And preferred standard notation is the same as engineering notation. Okay, all your calculators will do that, I'm sure. Unless somebody's got a steam-driven calculator from the 1970s or something. Okay, so that's that. Significant figures is always a thing that catches people out. So I've given you some rules here. Non-zero digits are always significant. So 1, 2, 3, 4, 5, 6, 7, 8, 9, always significant. Any zeros between two significant digits are also significant. So if it's 1, 0, 5, that's 3 significant figures. Okay? Leading zeros are never significant, and trailing zeros are only significant if they're part of a decimal number. So I've got some examples here. 12.34, you've got 1, 2, 3, 4. 4 non-zero digits, so it's got 4 significant figures. And in the second one, we've got 102.304, so that 0 is between two non-zero figures. That 0 is between two non-zero figures. So in this case, we've got 6 significant figures. Okay. In this case, we've got leading zeros, so they don't count. So we've only got 1 non-zero digit, so we've got 1 significant figure. Be careful, because lots of people say, oh yeah, you've got 3 significant figures because it's 0.003. You haven't, you've got 1. Okay, 600 here has 2 trailing zeros, so it has 1 significant figure. And in this case, rule 4, we've got 6.2600, and the fact that these zeros have been written here, these zeros, means that they are significant. So be careful about that. If I've gone to the trouble of writing 6.2600, what I'm telling you is I've measured this quantity to the number of significant places. So I've got 4 significant places, so it's 5 significant figures in this instance. Okay, be careful with that, make sure you understand it. Right, and that just about wraps up what I need to cover. So what I'd like to do now is to break out into the breakout rooms so that we can you can have a go at doing some of these. Okay, so I'm going to stop sharing my screen. If I can get the mouse to do what I want it to do, which is that. Right, so that's stop sharing the screen. Now I'm going to break out into the number of groups is going to be 3. Okay, so if I break out, I'll start that. So everybody is going to go into separate breakout rooms, and then somebody's going to come along and cover the questions with you. All right, so here we go.